finish up our surface area with cones. So again, we still have the formula of our lateral area. So we're going to take pi times our radius times our slant height. And then we're going to plug that into our surface area formula and then multiply that with our base area. So with this one, I'm just going to go right ahead. And since we're just working with pi and our radius and our slant height, I'm just going to type in, I'm going to write our formula of pi r squared plus pi rl. And I'm going to plug in what we know. Well, pi, what's our radius? 4 centimeters. So I'm going to take 4 squared plus pi times, we said our radius was 4. And then what's my slant height? 13. So 4 squared is going to give me 16. And then I'm going to take 16 pi. Oh, where's my pi button on here? That's going to give me 50.3, round to the nearest tenth, remember, plus, and then I'm going to take pi times 4 times 13, and that's going to get me 163.4. And then I just add those together, and I'm going to get 213.7 centimeters squared. Because remember, surface area we label with a square and not a cube. Questions there? Okay, then on our next one, we have our surface area equals pi r squared plus pi rl. So what do I get? I get pi times, what's wrong with this picture? It has a diameter, so how do I find my radius? 18 divided by 2, so I got 9. So I have pi times 9 squared. You can write your 9 in parentheses if you want to. As you see up here, I didn't write the 4 in parentheses. It just kind of depends. Plus pi times 9 times, what's my slant height? 19. So then I'm going to get 81 times pi, because 9 squared is 81. And I'm going to get 254.5 plus pi times 9 times 19 to get 537.2. And that's going to get me, good, 791.7 inches squared. Cubed is volume, remember, and we're working on surface area. So surface area is how much wrapping paper will it take me to wrap this figure. Volume is how much liquid can I fit inside of it. Do we have any questions on this? Would we like to do example 9? Or do we feel like cones are pretty straightforward? Okay. Then we are going to finish up with our last section in Math 8. It's the last thing we're covering. And then we have our final project to work on. You'll find out. Okay, we're going to finish up with spheres. Okay, so spheres are a 3D circle. There are different parts to the sphere. Well, a sphere is a solid in which each part is equidistant from the center point. The great circle slices the sphere into two hemispheres. So if I find the great circle on my picture here, it's going to be this dotted circle all the way around. That's my great circle. Okay. What do we think this little line is that goes halfway across? It's my radius. Okay, what's this guy right here, this dot? That's my center. And what's my full line up and down? That's my diameter. Okay. So those are the different parts of our circle or our sphere. It's important to remember that all points are equidistant from the center. So if my radius is going out here, it's going to have the same length of a radius that would be going diagonal. Okay, so just so you know that. Your radius can go any way and it's still the same length on anywhere you would have it on your circle. Okay, let's get to some examples then. So we're gonna find the volume first of each of these. Okay, so my volume formula for a sphere is volume equals 4/3 pi times our radius cubed, because remember, volume is cubed, surface area is squared. So what I'm going to do is I'm going to take 4/3 times pi times what cubed? 4 cubed. When I put that all in my calculator, you get 268.1 inches cubed. Okay. Then on number 2, I'm going to have 4/3 times pi times what cubed? 10.7. Very good. Because remember, like I said, your radius doesn't have to go sideways. It can go down. It can go diagonal. It's all the points are equidistant from that center. When you type that in your calculator, if you did it correctly, you should have gotten 5,131.4 meters cubed. What's wrong with number 3? It's my diameter. So how do I find my radius? 26 divided by 2, and that's going to get me 13. So then my volume equals 4/3 pi times 13 cubed. Now that sphere can hold 9,202.8 millimeters cubed. Questions on volume for a sphere? No? Let's move on to surface area then of a sphere. Surface area is a similar formula, but we're not dividing by 3. We just have 4. So now it's 4 pi, and then it's r squared. So if I look at number 5, I'm going to find the surface area now. So my surface area is 4 pi r squared. So I'm going to have 4 times pi times what squared? 7, because that's my radius. And when you plug that all into your calculator, you're going to get 615.8 miles squared. Okay, flip to the back side. Number 6. What's my radius? 18.5. Your radius doesn't have to be straight. It can be crooked. So I'm going to have my surface area equals 4 times pi times 18.5 squared. What'd you get? When I multiply those all together, $4,300.8 centimeters squared. What's wrong with 7? Has my diameter, so what do I need to do? Need to divide that by 2. So 32 divided by 2 gets me 16. So I have my surface area equals 4 pi times 16 squared. And then 3,217, I heard somebody say, yards squared. So, do we have any questions on cones and their surface area, spheres and their surface area, spheres and the volume, anything like that? All good?